Assalamu alaikum dear students. We are solving this exercise 6.5, and the question number 11 of this is, it is given that the function x raised to 4 minus 62x square plus ax plus 9 attains its maximum at x equals to 1. Now find the value of a, that is this function attains the maximum at x equals to 1. So we have to find find the value of a. Now the given function is x raised to power 4 minus 62x square plus ax plus 9. Now its derivative is given by 4x cube minus 124x plus a. Now it is given that x equals to 1 is the point of maxima, that is at x equals to 1 it attains its maximum value, which implies that x equals to 1 is the critical point, that is its derivative at x equals to 1 is 0. So substituting x equals to 1 in f dash of x, we simply get 4 into 1 raised to power 3 minus 1 to 4 into 1 plus a, or 4 minus 1 to 4 plus a equals to 0, or a equals to 101. Now the question number 13 is, find two numbers whose sum is 24 and the product is as large as possible. So this is the application of this maxima and minima in number system. That is, we have to find two numbers whose sum is 24 and the product is as large as possible. Now let x be one number, which implies that second number is 24 minus x, because sum is 24. Let f and x denotes the product of these two numbers, that is f of x equals to x into 24 minus x. Now its derivative is f dash of x equals to 24 minus 2x. Now it is given that the product is as large as possible. This means that we have to find the maximum value of this f of x, because f of x denotes the product of these two numbers. So using second derivative, f dash of x equals to 0, which implies that 24 minus 2x equals to 0, which implies that x equals to 12. So this means that x equals 12 is the critical point. Also second derivative is f double dash of x is minus 2. So at x equals to 12, f dash of x is minus 2, which is negative, which is less than 0. This means that x equals 12 is the, by second derivative test, is the local maxima, and the local maximum value is this f of 12 equals to, substituting in f of x, is 144. Now it is given that the two numbers, product of these two numbers, that is x and 24 minus x, is maximum, or is as large as possible, and the maximum value of this function, that is product function, is 144, which implies that x into 24 minus x equals to 144. So it is quadratic equation. Using quadratic rule, we simply get x equals to 12 and x equals to 12. So this means that x equals to 12, 24 minus x is again 12. Hence x equals to 12 and x equals to 12 are the two numbers, required numbers, whose sum is this whose sum is 24 and the product is maximum, that is, which is 144. Hence these are the required two numbers. Now another question of this type is, find two numbers x and y such that the sum of two numbers is 60, that is x plus y is 60, and the product x into y cube is maximum. Here x plus y is 60, which implies that y equals to 60 minus x. Let f of x denotes this product, that is f of x equals to x into y cube, replacing y by x, which is x into 60 minus x whole raised to power 3. Now it is also given that x into y cube is maximum. This means that we have to find the maximum value of this function by using the second derivative test. Now f dash of x is, by considering x as first function, 60 minus x cube as the second function. Now it is derivative, by using the product rule of derivative, is differentiation is 60 minus x square into 60 minus 4x. Now for critical points, derivative is 0, implies that 60 minus x whole square into 60 minus 4x equals to 0. Hence x equals to 60 and x equals to 15. Also double derivative, that is f double dash of x, is by differentiating f dash of x is 60 minus x into 12x minus 260. At x equals to 60, f double dash of 60 equals to 0. So by second derivative test we cannot say anything about x equals to 0, whether x is the point of local maxima or local minima. Similarly, at x equals to 15, f double dash of x is 60 minus 15 into 12 into 15 minus 260. Now 60 minus 15 is 45, that is positive. 12 into 15 is 180 minus 260. Now 180 minus 260 is negative number. This means that product of negative and positive is negative, hence whole value is negative, means less than 0. This means that by second derivative test, x equals to 15 is the local maxima, and the local maximum value is obtained by substituting x equals to 15 in given equation. Now when x equals to 15, this means that y equals to x minus 60 minus x, that is 45. Hence x equals to 15 and y equals to 45 are the required numbers whose sum is 60 and the product xy cube is maximum. Now we will use the maxima and the minima in its application in solid geometry. Now the question is, show that all rectangles inscribed in a fixed circle, the square has the maximum area. Now the rectangles inscribed in a circle means that these are those rectangles whose vertices lies on the circumference of a circle is called as the rectangle which is called as the inscribed in a given circle. Now we have to prove that the square is the rectangle which is inscribed in a circle with maximum area. Now let L be the length of the rectangle and B be the breadth of this rectangle inscribed in a circle of radius A. Now clearly the length of the diagonal of this rectangle is 2a, because 2a is the chord which is the diagonal, and if a is the radius implies that diagonal is twice a. This diameter of this circle is twice a, because diameter is here the diagonal of this rectangle which is inscribed in this fixed circle. Also in this, here we get a triangle. This means that by this Pythagoras theorem, hypotenuse square equals base plus perpendicular square, which implies that here hypotenuse is 2a square whole square plus L square equals to L square plus B square, or B equals to root of 4a square minus L square. Now the area of this rectangle inscribed in this is length into breadth. Let us denote this area by A. And here B equals to root of 4a square minus L square. This means area is L into root of 4a square minus L square. So this is the area function. Now we have to prove that area is maximum for squares inscribed in the circle. That is, we have to find the maximum value of this, under what conditions the maximum value of this area exists. For this we differentiate this area with respect to L. So on differentiating we get 4a square minus 2L square upon root of 4a square minus L square by differentiating this function and using the product rule of differentiation with respect to L. Similarly, double derivative, that is d2a upon dl square, is minus 2L into 6a square minus 2L square upon 4a square minus L square raised to power 3 by 2. Now for critical points, dA upon dL is 0, which implies that 4a minus 2L square is 0, or 2L square is 4a square, which implies that L equals to root 2a. So the length of this rectangle is L equals to root 2a. Now at L equals to root 2a, double derivative, that is d2a upon dl square, is minus 4, which is negative. Hence L equals to root 2a is a local maxima. This means that the maximum area of this is only possible when L equals to root 2a. Now when L equals to root 2a, corresponding B equals to 4a square minus root 2a ka whole square, that is substituting this L equals to root 2a in this B, that is here, we get B equals to root 2a. This means that area is maximum only when L equals to root 2a and B equals to root 2a. When L equals to B, this means that this rectangle is actually the square. Hence, the square is the only rectangle inscribed in the fixed circle with maximum area. So inshallah, in tomorrow's video lecture, we will discuss few more, questions of this type, that is how we apply the maxima and the minima in solid geometry. So thank you.